Hey guys, so in today's video, I'm going to discuss some questions on joint continuous random variables. So earlier, I had made three or four videos on joint continuous random variables, but I then started sharing some other videos and started making videos on some other topic, right? Like multivariable optimization. I also shared a proof of correlation and why it lies between -1 and 1. Post that, I made a video on gamma distribution and how to calculate the expected value, the moment generating function, and the variance of gamma distribution. But now I feel I need to start making more videos on joint continuous random variables. So in this video, I'm going to discuss two questions mainly, which will be covering how to find the conditional PDFs and the marginal PDFs along with solving for the limits, right? Hmm. Another thing, I'll be covering one more subtopic in joint continuous random variables, which is polar coordinates. That kind of questions or that specific type, I'll be covering later on. Right now, I want to move from joint continuous random variables. After discussing this, I want to go into transformations where I try to find the PDF from the CDF of two random variables. So I've discussed CDF to PDF of one single random variable, but now I think I need to discuss that also, right? Where you make a matrix and all of that. It is a long process, but I want to discuss questions on that topic. Uh, so yeah, let's just start now. Hey guys, so this is the question that we are dealing today, and I want you guys to take a look so that uh, you can get a clear idea of what I'm doing today. Though I'll be writing the question again, but I just want you guys to have a look. Then I'll be, zooming out a bit. So this is the question. The question says that joint distribution of x and y is given by fx comma y is equal to 4xy e to the power minus x square plus y square. X is greater than equal to 0, y is greater than equal to 0. Hmm. Test whether x and y are independent. For the above distribution, find the conditional density of x given y equals to y. So this is my question. Now I'll just zoom out. Hmm, 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 hmm. Hmm. So this is our question. Now I'll be just starting with the solution. Hmm. So the question says that we are given a joint distribution, right? So the joint distribution is hmm. So sorry. Hmm. Hmm. So the question says that fx comma y. So sorry. Sorry guys. So fx comma y equals fxy e to the power minus x square plus y square greater than or equal to 0. Y is greater than equal to 0. Right? This is my question. Right. So now we need to check if x and y are independent. And what does independence mean? Independence means that fx comma y turns out to be equal to the product of the independent marginal distributions, right? So if I try to find fx, let's just find fx. So for finding fx, what I need to do is I need to find fx comma y with respect to dy, and I'll put in the limits of y, and y is greater than equal to 0. So I'll be putting the limits as 0 to infinity, right? And for f of y, what I'll be doing is from 0 to infinity, these are the limits of x, right? fxy x. I have discussed all of this in my previous videos of joint continuous random variables. So please take a look at those videos. Uh, there has actually been a long break in between. So I used to make these videos on joint continuous random variables 6 months back, and then I was busy with something, so I couldn't give much time to my YouTube channel. And then I started making videos on multivariable optimization. That playlist is already going on. You can check that out. A new video is coming out soon. So that is the reason why I was not able to focus on this joint countries random variables videos. And now I'm starting with it again. So if you were watching it previously, I would humbly request you to please either rewatch those videos again or just revise the topic so that you get what I'm doing, right? And I'm so sorry that it took me such a long time to come back to this series, right? So this is my this is my PDF, right? Now I should write. Now I'll be treating x as a constant, x and 4 as a constant, and e to the power minus x square also as a constant. So I only have e to the power minus y square dy, which I need to integrate, right? So I'll be taking out 4x e to the power minus x square out, 0 to infinity, and I'll be left with e to the power minus y square dy. This will fetch me fx is equal to 4, 4x e to the power minus x square and e to the power minus y square. Now e to the power minus y square, 0 to infinity. Let me see. E to the power minus y square. Hmm. This is a special kind of an integral. So I need to do some manipulations to solve this. Wait a minute. So the form of gamma integral is, or I can use e to the power minus y square.
Wait a minute. I have another term here, right? Oh, I've missed something. I didn't. I missed y here, right? So this was. This was. Wait a minute. I missed a term here. So I ignored y from this. So this was 4x. Now this is 4x, 0 to infinity, and this is y e to the power e to the power minus x square y e to the power minus y square dy. Hmm. 4x e to the power minus x square 0 to infinity y e to the power minus y square, right? So now if I just integrate this, now this can be integrated easily. Yeah, so I can apply isolate. Let's apply isolate here. So this will be or let me just substitute. So y square is equal to t and 2y dy is equal to dt. So this gives me y dy is equal to dt by 2. And also y goes to when y square goes to when y goes to infinity, my t which is equal to y square also goes to infinity. When y goes to 0, my t which is equal to y square also goes to 0, right? So now my limits are the same. I have 0 to infinity. Now e to the power minus t, e to the power minus t, and d by y dy. So y dy becomes dt by 2, dt by 2, right? So this is my integral. So if I just solve it here, fx is equal to 4x 4x e to the power minus x square, and half comes out, and this gives me e to the power minus t minus 1, and the limits are 0 to infinity. This gives me, this 2 and 4 gets cancelled, and I'm left with 2x e to the power minus x square and minus 1 upon, so this becomes minus infinity, this becomes e to the power minus infinity is 0, minus e to the power 0 becomes 1, so this is positive 1, this is positive 1. So finally this becomes 2x e to the power minus x square. So fx is equal to 2x e to the power minus x square, and fy, similarly fy will become 2y e to the power minus y square, because the distribution is turning out to be symmetric, right? Because you can see that here also limits are from 0 to infinity, and this distribution is also symmetrical, kind of symmetrical, right? So similarly we can say that this and this is our marginal PDF, right? Now we need to check if this condition satisfies. If this satisfies, then we will say that yes, x and y are independent, if this satisfies, but we don't know if this satisfies or not, right? So I'll just rub this portion a bit, because we are checking this, right? Now now my fx was 2x e to the power minus x square, 2x e to the power minus x square. Fy was 2x e to the power 2y e to the power minus y square, right? So fxy, so fx into fy becomes 4xy e to the power minus x square plus y square, and this is actually equal to fx comma y, because my fx comma y was equal to 4xy e to the power minus x square plus y square, right? Therefore yes, x and y are independent. Also here I need to mention that x is greater than 0, y is greater than 0, right? Now we need to show that, so no, we need to find this, we need to find the conditional density of x given y. Conditional density of x given y is xy, right? So we need to find this. So for finding this, the formula for this is f xy divided by f of y, right? So we already have f of y. F of y was this 2y e to the power minus y square, and fx comma y was 4xy e to the power minus x square plus y square, right? So this gives me fx conditional y equals 4xy e to the power minus x square plus y square divided by 2y e to the power minus y square. 2 y and y gets cancelled, and this gives me x upon e to the power minus x square, e to the power minus y square, e to the power minus y square, and this gets cancelled. So ultimately we get x e to the power minus x square. And x should be greater than 0 here, right? For x is greater than 0. Now let me check if my answer is correct or not. I have 2 missing here, right? Yeah, so 2 was also present here. So right, yeah, 2 was also here. So right, 2x e to the power minus x square. 2x e to the power minus x square, yeah. And x is greater than equal to 0. X is greater than equal to 0, though it doesn't matter in continuous distributions. So I just missed the 2 here, right? After cancelling 4 in the numerator and 2 in the denominator, I should have been left with 2 in the numerator, so I forgot to write that. Otherwise, what we have done is perfectly fine. So let's move on now. Let's move on. Example. Let's solve example 5.44. Or instead of example 5.44, mm, mm, so let's solve example 5.47, and I'll take up 5.44 in the next video, right? Because 5.47 is more relevant to us right now. Hmm. So this is the question that is given to us. Example 5.44 is also very relevant, but I'll be taking up that question in the next video, right? Also, uh, a few examples in between are focused more on polar coordinates kind of questions, right? So I'll be taking that also separately because I want to give that topic a little more time. That's why. So now let's just start with this question. So this is question number 2 of today. So this question says that, wait a minute. So this question says that fx uh, fx comma y is equal to fx comma y fx comma y is equal to e to the power minus x plus y, and we are given an interval. And so basically we are given that let me just write it. Let me just write the answer. Let me just write the question. Fx comma y is given to us e to the power minus x plus y, and they've given to us that x lies between 0 and infinity, y lies between 0 and infinity. So this is the question that is given to us. Now the first part says that we need to find the probability of x greater than 1. So for finding the probability of x greater than 1, we need to find f of x. So f of x is basically 0 to infinity e to the power minus x plus y dy, and these are the limits of y, right? So y also lies between 0 and infinity only, right? So this will give me f of x. So f of x is e to the power minus x and e to the power minus y, 0 to infinity and minus 1 after integrating this, and this ultimately gives me e to the power minus x, e to the power minus infinity, 0, minus 1, plus 1. So yeah, this is my final value. So f of x is e to the power minus x. Now for finding the probability of x greater than 1, I need to integrate this f of x dx over the limits 1 to infinity, right? So this becomes e to the power minus x dx 1 to infinity. So this becomes 0. X is greater than 1. Wait a minute. So this becomes e to the power minus x minus 1 divided e to the power minus x divided by minus 1, and the limits are 1 to infinity. So this becomes probability of x greater than 1 becomes e to the power, or this becomes minus 1 and 0. E to the power minus 1 is e to the power minus 1, right? So this becomes positive e to the power minus 1. So this is my first answer. E to the power minus 1, right? So this is our answer. Let me check. Yeah, so they have written 1 upon e, and both of these things are the same thing, right? Mean the same thing. So the second part says that probability of x less than y, conditional probability of x less than 2y, probability of x less than y, probability of x conditional probability of x less than 2y. this is y greater than x, and this is x greater than y. Yeah. So now we need to find write the line for x less than 2y. X less than 2y. Actually, this is not needed, but fine. X less than y and x less than 2y. So I'll be making a different diagram for that. Right, so this is my y-axis, this is my x-axis, right? And we need this x less than y, so we need this area. We need this area, right? Because this line is x equals to y, passes from the origin, right? So this is the origin, and this is y greater than x, and this is x greater than y. So now we need to find probability of x less than y, condition x less than 2y. So this means that we need to find the probability of x less than y intersection as x less than 2y and divided by x less than 2y. So probability of x less than y intersection probability of x less than 2y basically means that probability of x less than y. So for finding the probability of x less than y, what we need to do? We need to look at this diagram, right? So x less than y. So basically I can write this as probability of x less than y. Probability of x less than y means we know that x lies between 0 and infinity. We know that y lies between 0 and infinity. And we know that we need to find the probability of x less than y. So basically x lies between 0 and y lies between 0 and infinity. Right, so we can use this. So probability of x less than y, or if I show you this through the diagram, if I am taking y lying between 0 and going towards infinity, I can say that my x lies between 0 and can at the maximum reach to y. So basically if this was, so let my y vary from 0 to 10, right? If my y was varying from 0 to 10, I would be saying that my x varies from 0 to, now the maximum value that my x can take is this, because y always has to be greater than x. So at the max this will be x lies between 0 and y. So y is 10 in this case, so x is always less than 10. But because we don't have any exact value, or even if we had an exact value, we always say that it is less than y. You can also see that right? So this is any value on this y-axis. Any value on this y-axis will be any number which is equal to y, right? So we can say that x lies between 0 and y, because this is the maximum value that x can attain. So for example, if y is 10, we can just draw a line which is connecting to this, which is joining to this line, or which is intersecting this line, x is equal to y, and from that we can draw another line which is pointing towards the x-axis, and there we get the x. Or if I show you here, right? So if I have a diagram, and if I have x equals to y, and if I have y equals to 10 here on the y-axis, I can just draw a line here, y equals to 10, and this will be intersecting x-axis. This x is equal to y at this point, and if I draw a line, x is equal to 10 here, I'll be getting the value of x, right? This was a bit complicated, but I hope you get the idea. Basically x lies between 0 and the max value that x can attain will be we'll be getting that from this line, x is equals to y. Again, if you have any doubts regarding this, I can make a separate video explaining this more deeply. I don't know if you get the intuition behind this. This is not, something that you need to visualize or think about it very deeply. But if you still have some doubts, or you weren't, satiated enough with my explanation, that I can make another video on this, right? Hmm. So now we need to find this. So I've already told you my my PDF is e to the power minus x plus y, and this will be dx dy. Now my limits for my x is 0 to y. My limits for my y is 0 to infinity. This means that probability of x less than y, 0 to infinity. Now this means that e to the power minus y is a constant, so I'll be taking that out common, because we are integrating first this expression we are integrating first, and then dy will come into play, right? So ey, and this becomes e to the power minus x minus 1 after integrating, and 0 to infinity, and dy will come. So this will give me 0 to infinity e to the power minus y, e to the power minus infinity becomes 0, 0, and e to the power minus 0 becomes 1, so minus minus 1 plus 1 again, yeah, so plus 1 e to the power minus y dy, and this again gives me e to the power minus y minus 1, 0 to infinity, again this gives me plus 1, right? Right. Now now we need to find the probability of this x is less than 2y, probability of x less than 2y, probability of x less than 2y, because this will be coming in the denominator. For finding this, what I'll be doing is I'll be repeating the process. This is my y-axis, x-axis. Now this is x is equal to 2y, so this needs to be a bit flatter, right? Because the slope has become half of the previous value. So x is equal to 2y. So this will be slightly like this. Wait a minute. Hey, why is my rule not working? This is the line. This is the line, x is equal to 2y. I hope you guys can see x is equal to 2y. Now this is my y-axis, this is my x-axis, or if I just extend this, this is my x-axis, right? And I need to find x less than 2y. This was x less than y and x less than 2y, right? So for x less than 2y, I need this. I need this portion, right? This portion. I need this portion, because this is 2y greater than x, or I can say this portion, and I can say this portion is 2y less than x, right? So for this I can say that my x lies between 0 and 2y, my y lies between 0 to infinity. Again, this is 0 and this is going towards infinity, right? This is 2y less than x, right? Now if I just find this, this will be again 0 to 2y, and this will be 0 to infinity e to the power minus x plus y, right? This was my PDF, e to the power minus x plus y, d dx dy, and this will be 0 to infinity e to the power minus y, e to the power minus x minus 1, 0 to 2y dy, and this means that oh, wait a minute, I made a mistake here. This should be y. this should be 0 to y, right? So my limit becomes e to the power minus pi and e to the power minus 0, so becomes minus 1. So this is different. Wait a minute, I made a blunder. Here. So this becomes so e to the power minus x minus, and this becomes, my limits are from 0 to y, so this is e to the power minus y minus 1, or I can say 1 minus e to the power minus y, right? So if I just erase this, 1 minus, this becomes ultimately I'll be having e to the power minus pi, and after integrating minus 1, and this becomes positive e to the power minus 2y. Wait a minute. So positive e to the power 2y by 2 minus e to the power minus y minus y becomes minus 2y divided by minus 2 plus 2. So this becomes 0 to infinity now. So what I have is, ultimately what I have is if I just zoom this a bit, so this becomes probability of x less than y becomes e to the power minus pi becomes 0 and 0, and minus 1 minus 1 positive 1, 1 minus 1 by 2, 1 minus 1 by 2, 1 minus 1 by 2, which is half. Therefore my probability of x less than y is half. So sorry, I made a blunder here, right? So I took the limit as 0 to infinity only. Even after writing the right limits, I did something, I messed something, so therefore it is a blunder, right? Now coming back to our question, the same process that we did just now. So this becomes e to the power 0 to infinity e to the power minus pi, and again this becomes e to the power minus 2y positive 1 dy. So this gives me e to the power minus e to the power minus 3y. So after integrating, this will become minus 3y, and this minus sign gets cancelled, minus 3 comes in the denominator, positive, and I have positive, I have positive e to the power minus y and negative 1. So I can write this as, directly I can write this as, I can just put the negative sign in between, and here I'll be putting a positive sign from 0 to infinity. This will give me from 0 to infinity, so this will give me e to the power negative infinity becomes 0, and then e to the power 0, okay. So this becomes 0 and minus 1 by and minus 1 by 3, minus 1 by 3, and positive 1. So this becomes 2 by 3, right? So my now we need to compute this, right? So finally my probability of x less than y, conditional x less than 2y, which was probability of x less than y intersection x less than 2y divided by probability of x less than 2y, which becomes probability of x less than y divided by x less than 2y, gives me probability of x less than y was 1 by 2, and this was 2 by 3. So ultimately what I have is 3 by 4. So this is my final answer of probability of x less than y, conditional x less than 2y. This is 3 by 4, right? So if I just check my answer, x less than y was half, and x less than 2y again was 2 by 3. So my final answer is 3 by 4, right? So I think I should end the video here now, right? Oh, wait a minute. We have another part. We have another part that we need to solve. This video has become long. I wanted to make this into a short video, but now we are stuck with this only. So the third part says that the third part. Well, let me just show you the question again. The third part says that x plus y lies between 1 and 2. This is a good question. Covers a lot of things. That's why I discussed this first before moving on to polar coordinates. So probability of x plus y lying between 1 and 2. Probability of x plus y lying between 1 and 2, right? We need to find this. So the probability of x plus y lying between 1 and 2. We can break this into two parts, right? So I can write this as probability of x plus y lying between 1 and 2. What I can write this as? I can write this as probability of x plus y less than 2 minus probability of x plus y lying less than 1, right? So less than 1. So basically, if we imagine a bell curve, now there is no role of bell curve here, but just to explain you guys, if there was a bell curve and we need to find the probability between this -3 and +3. So if this was x equals to minus, oh wait a minute, so this was +3 and this was -3 and this is 0. So let me assume this is x plus 3 and x is equal to -3. Now we need to find this probability. So for finding this probability, what I can write this as? Probability of x less than 3, the CDF. So the CDF, this means that I have probability x less than 3 means that probability of x less than 3 is equal to, this is the area that we need to find, right? So probability of x less than 3 is this whole area, and probability of x less than -3 is this whole area. So if you subtract this area, from this whole area, you will be getting this area, x lying between -3 and 3, and that is what we did here. To find the probability of x plus y lying between 1 and 2, we found the probability of x plus y less than 2 and subtracted this probability x plus y less than 1 from this, right, to get the value of x plus y lying between 1 and 2. So now to find probability of x plus y less than 2, let's just find probability of x plus y less than, let's just find probability of x plus y less than 1 first, because if we find the probability of x plus y less than 1 first, and then we find the probability of x plus y less than 2, we can check if our answer is correct or not. So this is a very basic thing. The probability of x plus y less than 1 should be less than the probability of x plus y less than 2, right? Because x plus y less than 1 has a fewer compatible values compared to the set of x plus y less than 2, right? So essentially probability of x plus y less than 1 should come out to be less than probability of x plus y less than 2, right? So probability of x plus y less than 2 less than 1. So we need to find this, right? We know that x and y both lie between 0 and infinity. So for this, what we can do is we can just draw a graph, and this is my x-axis, this is my y-axis, and I need to draw a line x plus y less than 1, x plus y less than 1, or I can say that x plus y equals to 1 and y equals to 1 minus x. So I'll be drawing this line, y equals to 1 minus x. So when x is 0, my y is equal to 1. So when my x is 0, y is equal to 1. This my x is, oh wait a minute, yeah. So when my x is 0, yeah. And when my x is equal to 1, my y is 0. Okay. So this is a line like this, right? A downward sloping line. So we need to find x plus y less than 1. So this area is essentially x plus y greater than 1, and this area is probability of x plus y less than 1. Actually, this whole area, if I just extend this line, this whole area is probability of x plus y less than 1, and this is the second quadrant, this third, and this fourth. But we also know that x and y are lying between 0 and infinity, so we need to, you know, not take these quadrants into account. So now if I just clean my diagram a bit. Hmm. Right? So we need to find this area. We need to find this area, right? This is x plus y less than 1. um, hmm. So from here we can say that this is 1 and this is 1. So if I just take the value of x first, I can write this as x lying between 0 and 1, x lying between 0 and 1, and y lies between 0 and this. This line was x plus y equals to 1, or I can say y equals to 1 minus x, and I also know that we are taking into account this area only, and this area is y less than 1 minus x. So I can write the limits as, for finding probability of x plus y less than 1, I can write the limits as x lying between 0 and 1, and y lying between 0 and 1 minus x, because as soon as we go upwards, move upwards, we have already taken into account the values of x, right? So we are keeping the values of x ranging from 0 to 1. Now we need to write the limits for y, and as soon as we start from 0, from this point, as soon as we move up, we encounter this line, and we cannot go above this line, right? We cannot take values of y above this line. So we are writing that y lies between 0 and 1 minus x. So now I can just take this as 0 and 1 minus x, and I'm taking the values of x as 0 to 1. So we need to take one variable which has some proper values like 0 to 1, no variables, and we need to take variable, one random variable having the limits also in some other variable, right? In the second variable, right? So for finding this, what I need to do, my PDF was minus x plus y, right? Minus x plus y, right? Yeah. And this is dy dx. So my probability of x plus y less than 1 turns out to be 0 to 1 e to the power minus x, e to the power minus y, minus 1, 0 to 1 minus x. This gives me 0 to 1 e to the power minus x, and 1 when it is 0. So 1 minus 1 minus 1 minus 1 positive 1 e to the power minus 1 minus x dx. So I don't have space to write dx, I'll be writing dx here, right? Dx. So this becomes 0 to 1 e to the power minus x and minus e to the power, now minus minus positive, and this becomes minus 1 positive x minus x, so this becomes 0. So this gives me this term only, and I'm left with e to the power minus x minus 1 minus minus positive e to the power minus 1 minus 1. So this minus minus gets cancelled, e to the power minus 1 divided by minus 1 minus 1 minus 1 positive, and from 0 to 1 this gives me e to the power minus 1 minus 1 positive e to the power, wait a minute, this was completely bullshit, so sorry. This was a constant term, I again treated this as a variable, sorry. And this should be x, right? So this is e to the power minus 1 divided by 1 minus, wait a minute, I made so many mistakes. I don't know, I'm in a hurry to finish the video, that's why I'm making so many mistakes. because now otherwise the video becomes too long and people don't watch the video. And now minus e to the power minus 1 and 1. So this becomes minus e to the power minus 1 plus 1 minus e to the power minus 1. So probability of x plus y less than 1 becomes 1 minus 2 e to the power minus 1. 1 minus 2 e to the power minus 1. I hope what I'm doing is correct. Let me just check once if what we have done so far is correct or not. Seems like it is correct, but we need to check that at the end. I have taken the limits properly. Now for finding the probability of x plus y less than 2, again I'll be drawing a line and this is the area that is of importance to us. Now I'm taking this in a different way, right? So I'm taking y to lie between 0 and 2 and x will lie between 0 and this line is x plus y equals to 2. So I can write this line as x and we need to take this area into account, and this area is x plus y less than 2. Hence I'll say that y lies between 0 and 2 and my x lies between 0 and 2 minus y, right? So my probability of x plus y less than 2, probability of x plus y less than 2 becomes becomes 0 to 2. This is 0 to, wait a minute, 0 to 2 minus y, and this is 0 to 2 e to the power minus x plus y dy dx dy, right? So this becomes 0 to 2 e to the power minus y e to the power minus x minus 1 e to the power minus x minus 1, 0 to 2 minus y dy, and this becomes 0 to 2 e to the power minus y and e to the power negative e to the power minus 2 plus y positive 1 dy, and this again becomes 0 to 2 negative e to the power, now minus y plus y becomes 0, negative 2 plus e to the power minus y dy is equal to 0, wait a minute, now this is negative, right? E to the power minus 2 and e to the power minus 2y and e to the power minus 2 into 2 e to the power minus e to the power 2 into 2 and e to the power minus 2 minus 1 and positive e to the power minus 2 into 0 positive e to the power 0. So this gives me 1 minus 3 e to the power minus 2. So finally I need to find probability of x plus y lying between 1 and 2, and this is probability of x plus y less than 2 minus probability of x plus y less than 1, which is equal to 1 minus 3 e to the power minus 2, subtracting the previous term, which was, and this was 1 minus 2 e to the power minus 1. 1 minus 2 e to the power minus 1. So this ultimately becomes 1 and 1 gets cancelled, and 2 e to the power minus 1 minus 3 times e to the power minus 2. This is my final answer. I need to check if it's correct or not. 2 e to the power minus 1 minus 3 e to the power minus 2. Right, so many calculations went into this. These were very basic calculations, but it takes time. Though they have done this in a very intelligent manner, they have made a diagram, proper diagram, and they have labeled two areas. So I could have used this method also, but if this comes up in an exam, I would prefer to use this method, because this I'm more comfortable in using this. Though I'll be uh, I don't know if I'll be making this, but if you guys want me to share another method of solving this question, I can. Though the method is same only, but they have made the diagram in a very different manner. Not very different, but they have made both of those lines, x plus y equals to 2 and x plus y equals to 1, on a single graph only, and then they have labeled different areas. That is actually a very efficient way, but I am more comfortable in doing this. And if you want me to share that method also, just let me know in the comments, and I'll be uploading one more video. Again, I'll be attaching the link of my working, the PDF of which I have solved, in the description of my video. If you want, you can go and check that out. If you find any discrepancies or any problems in my work, please let me know in the comments. If you have any doubts, let me know in the comments. Again, please share my video, subscribe the channel, and like the video. Do put in a comment, it encourages me to keep on making more videos. Thank you, and I'll see you in the next video. Bye bye.